Lesson 51, negative exponents and scientific notation for small numbers. First off, let's look at negative exponents. We've already learned that when we multiply like bases, we add the exponents, and when we divide like bases, we subtracted the exponents. But what if our exponents are negative? Well, the law of exponents for negative exponents says remove negative exponents by writing the reciprocal of the base with a positive exponent. So here, x to the negative nth power, the reciprocal of x to the negative nth is 1 over x to the nth power, and the exponent is positive. Because remember, you cannot have a negative exponent in your answer. The very small numbers are written in scientific notation with negative exponents. The answer is still going to be positive, but it's got a negative exponent on it because it's a very, very small number. So let's take a look at some examples. Which of the following does not equal 10 to the negative third? Now, somebody might look at that and say, well, that would be a negative 1,000. But this negative exponent does not tell you whether your number is positive or negative. That just tells us which direction our decimals got to go. So if we have 10, our decimal is here. When you have a negative exponent, it has to go to the left. So if I go 3 to the left, this is where my decimal would be. And so I have my number right there. So we know is 0.010. So if you look at our choices, which of the following does not equal that? We know that it cannot be D, negative 1,000, because our answer is a positive answer here. I'm going to just erase this part right here because this is not in scientific notation. But 10 to the negative 1/3, that's the same thing as doing 10 to the third because of the reciprocal. 10 to the third is 1,000th. Letter C, this is the thousandth place right here. So that's why it can be C, it can be B because that's simplifying 10 to the third. And then 1 over 10 to the third is the same as reciprocal of 10 to the negative third. The second example, find the missing exponent. Remember, when you multiply like bases, you add the exponents. The negative 2 plus a negative 4 gives us a negative 6. And then when we divided like bases, we subtracted the exponents. So this one is a negative 2 minus a negative 4. And remember, when we subtract a negative, you're really adding its opposites. So negative 2 plus 4 is a positive 2. So it would be 10 to the second power. Let's simplify these other problems. 2 to the negative third. Since it's got a negative exponent, I need to make it positive by writing the reciprocal of the base. So it would be 2 to the third, 1 over 2 to the third, which is 1 over 8. Then I have negative 2 raised to the third power. That means I'm writing negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is positive 4. Positive 4 times a negative 2 is a negative 8. Now you notice that my exponent is positive, so I don't need to do the reciprocal. 3 squared times 3 to the negative second. You multiply like bases. I add the exponents. So 2 plus a negative 2 is 0. 3 to the 0 power is just 1. And then I have some with variables in it. So I know I'm going to have 3 in my answer. X to the negative first plus 2 gives me just x to the first. And then I have y, 1, plus y to the negative seconds gives us y to the negative first. And then I have a z. If but I can't have negative exponents. Remember, this is all over 1. I need to put this y to the bottom to make that positive. So my answer would be 3xz all over y. And that would be my answer. Just remember, with your negative exponents, you flip it or use the reciprocal of the base to make the exponent positive. Some other practice problems. 3 to the negative second. Since I have a negative exponent, I write it with reciprocal. So 1 over 3 squared, which would be 1 over 9. 2 to the negative third, that's the same as saying 1 over 2 cubed, which is 1 over 8. 5 to the 0 power, anything to the 0 power is just 1. 2 to the negative third times 2 to the third, I add the exponents, gives me 2 to the 0 power, which is just equal to 1. Find the missing exponent here. 10 to the negative third times 10 to the negative fourth, I add the exponents, that gives me 10 to the negative seventh. And then simplify with these variables. I have x to the negative third plus 1. That gives me x to the negative second. And then I have y squared plus a negative 1. That just gives me y. I need to make this so I don't have negative exponents. So I have y on top. And I have x squared on the bottom. So that would be my answer. And the last one here, 6 divided by 2 is 3. X squared, x to the negative second, divided by 1x, so I'm subtracting 1. So that gives me x to the negative third. I have my y's, so that's 3 minus 1, because I'm dividing by a y. That gives me y squared. And I have a z to the negative first. Now I can't have negative exponents, so the 3 stays on top because it's positive, or because there's no negative exponent on it. Y squared stays on top because that's positive exponents. My x to the negative third has to go to the bottom to make it positive. Should be x cubed. And then I have z on the bottom as well. So my answer would be 3y squared over x cubed z. Next is looking at standard form in scientific notation with really small numbers. So we want to write this number in standard form where I could as a decimal. So 10 to the negative fourth power. So this is be rewritten as 1 over 10 to the fourth, which is 1 over 10,000. So if I have, here's my tenths, hundredths, thousandths, 10,000ths. So 0.0001. 1.5 times 10 to the negative third just means move it 3 places to the right or to the left. So 1, 2, 3. Fill everything else with zeros. So this would be 0.0015. Then we have 5 times 10 to the negative fifth. The decimal point is here. So 1, 2, 3, 4, 5. So my answer would be 0.00005. Then I have 2.5 times 10 to the negative second. Move it 2 places to the left. So I would have 0.025. So you can see why we would write these numbers in standard form in scientific notation, because it's a lot easier to read 1.5 times 10 to the negative third than to say 0.0015 or 15 10,000ths. Other problems, the diameter of a red blood cell is about 0.000007 meters. Write that number in scientific notation. So I know my decimal's gotta be between 1 and 9. So I know it's gotta be 7 times 10, and I moved it 1, 2, 3, 4, 5, 6 places. But my number in standard form is less than 1. So this has to be a negative 6. So it would be 7 times 10 to the negative 6 meters. Rate 0.008 in scientific notation, so this is 8 1,000ths. So this should be 8 times 10. I moved it 1, 2, 3 places, so negative 3. And the last one, 0.000125 in scientific notation. I need to have my decimal between 1 and 9, so 1, 2, 3, 4. So it'd be 1.25 times 10 to the negative 4th power. And some final problems working with word problems. If lightning strikes a mile away, the sound reaches us in about 5 seconds, but its light reaches us in about 5 millionths of a second. Write 5 millionth in scientific notation. So let's write this as a decimal first. So we got 0, tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. So that's our decimal. We need to write that in scientific notation. So if I move it 1, 2, 3, 4, 5, 6, I have 5 times 10 to the negative 6 because this is less than 0, or less than 1. So it'd be 5 times 10 to the negative 6 seconds. And the last one, a nanometer, is 10 to the negative 9th meter. Write that number in standard form. So this would be 1 over, we have to have 9 zeros, 3, 4, 5, 6, 7, 8, 9. So this would be 1 millionth. So to write that in standard form, we would have 0.10ths, hundredths, thousandths, 10,000ths, 100,000ths, 1 millionth. I actually had that wrong. Because if we were to put this in scientific notation, let me erase that. We would have 1 here in the decimal, move it 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. Fill these with zeros. So we would have 0. We got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this would be our answer in standard form. So that is our lesson today on negative exponents and scientific notation for small numbers.